tangent and normal to a circle. At the end of this lesson, you will be able to define tangent to a circle, explain the different forms of the equation of tangent, problem based on tangent to a circle, define normal to a circle, explain the different forms of the equation of normal, problem based on normal to a circle. We are all well aware of circles. I mentioned about circles, but I am showing you a sphere, right? But I can make the sphere into a circle. We can frame many circles from a sphere. Now, I consider a circle which has the highest circumference of the globe. Let us first see what is tangent to a circle. A tangent to a circle is a line that touches the circle exactly at one point. What about the normal to a circle? A normal to a circle is also a line that is perpendicular to a tangent to a circle. Why should we study the tangent and normal to a circle? In our world, many things have the tangent and normality to a circle. The cycle wheel is a circle and the land acts as the tangent. The spokes of the wheel are the normal. In the construction of buildings, the tangent to a circle is very important for aligning circles and creating useful patterns. Here, the normal is used to design the circles. Let us study about the tangent and normal to a circle briefly. Let us see how to draw tangent and normal to a circle, which will be useful in the real-life applications of this topic. Consider a circle with center O. Draw a line segment from the center O and take the end point of the line segment as P. We have to draw the perpendicular bisector of the line segment OP. To draw the perpendicular bisector of OP, place the compass at O, open the compass a little more than a half of OP. Place the compass at O and mark two arcs above and below of OP. Similarly, place the compass at P and do the same thing. Join the intersection points of the two arcs. We get the perpendicular bisector of OP and that intersects OP at M. Thus, M is the midpoint of OP. Now, draw a semicircle about to the line segment with radius OM at the center M. This semicircle intersects the given circle at a point. Let the point be A. Join AP. Hence, the line AP represents the tangent of the given circle. Now, let us define how to draw the normal to a circle. Draw the radius O to A of the given circle, which is perpendicular to the tangent. Therefore, the radius OA is called as the normal to the given circle. Let us now see an application of tangent and normal to a circle. For instance, if Junko Tabe, the first woman to climb the Mount Everest, reaches the summit and wants to measure the distance from the summit to the starting point in miles, will she be able to measure? Yes, she will be able to measure the distance from the summit to the starting point in miles. But she has a major problem that the globe is not flat. It is spherical and it is not possible to scale. If she wants to measure the distance, she has to consider the circle of the sphere with highest circumference. If she finds she can absolutely measure the distance. Let us see how it is done. Now, we want to form the diagrammatic representation to measure the distance. If we consider the highest circumference circle of the earth, then center of the circle is C and the starting point of Junko Tabe is H. Also, consider the summit of the Mount Everest as E. If we consider the distance from the starting point H to the summit E as a line, then we can also take this as tangents because it touches the earth exactly at one point, thus the starting point H. Also consider CH as radius and EC as hypotenuse. We know that the height of the summit above the sea level is approximately 29,000 feet above the sea level. The radius of the circle CH is 4,000 miles approximately. The distance from the center to the summit, that is, EC, is the summation of the radius and the distance from the sea level to the Mount Everest. As the radius is perpendicular to the EH, we have the angle H is equal to 90 degree. Thus, triangle ECH is a right-angled triangle. So that we can apply the Pythagoras theorem to find the distance from the summit to the starting point. Applying Pythagoras theorem, we have AC square is equal to EH square plus HC square. Substituting the known values, we obtain the equation as shown. We want to find the distance in miles, but the height of the summit is mentioned by the feet measurement. We know that 1 mile is equal to 5,280 feet. Thus, 1 foot is equal to 1 by 5,280 miles. Substituting this to convert the feet into miles. Substituting, we get the value of EH square as shown here. On solving, we get EH square is equal to 43,969.56. Thus, EH is equal to 209.68 miles. Rounding off to the nearest integer, we get the measure of the distance from the summit to the starting point to be 210 miles. We all know that the satellites are launched to monitor the cloud patterns for weather changes, to send television signals, and etc. But how does it work? Our planet has many stations connecting to the satellite. Do you accept the path of a satellite to a station is a tangent? Come, let us see how it makes a tangent path. Consider any stations of the satellite on the Earth. Assume that the Earth is the circle with center C. Then it has an equation as shown. How can we find the tangent to a circle? We already know the point-slope form as shown. When this equation passing through the tangent point P, then it forms the tangent equation. To form the equation of a tangent, we need two things, a point and a slope. If we consider the station 1 as the point on the circle, it can be written as shown. Next, we want to know the slope of the radius CP because P is the point which touches the tangent at exactly one point. The general form of the slope is m is equal to y1 minus y2 by x1 minus x2. Here, x1, y1 denotes the points of P and x2, y2 denotes the points of the center C. We already know that the center of the circle is minus g minus f. Substituting the center value in the general slope equation, then we get the slope of CP from the point to the center C can be written as shown. Now, we have to find the slope of the tangent line PT. Here, the radius CP is perpendicular to the tangent line PT. Therefore, the slope of the PT is nothing but the negative reciprocal of the normal due to the perpendicularity. Substitute the value of CP, then the general form becomes as shown. Therefore, we get the slope of the tangent line PT. We are aware of the equation of a line with single point P. Here, m is the slope of tangent. Substituting the slope of the tangent in the equation, we get, taking the denominator to the left-hand side, we get, on simplification, make the right-hand side as 0. Multiplying and rearranging the terms, we get, in our previous topics, we studied the equation of circle. Here, we will use the equation of circle to form the tangent equation. To form the equation of circle, adding gx1 plus fy1 plus c on both sides and simplifying we get, hence we get the equation of circle. So the right hand side becomes 0. Thus the required equation of tangent at the point is as shown. This equation is called the point form of the tangent equation. If we consider the equation of the circle at the point as shown, then the equation of the tangent can be written as shown on the screen. This equation is called the parametric form of the tangent equation. Similarly, if the equation of the circle at the point is as shown, then the equation of the tangent can be written as shown on the screen. This equation is called the slope form of the tangent equation. Therefore, we have three different forms of the equations of tangent as point form, parametric form, and slope form. Let's solve a problem based on tangent to a circle. Find the equation of the tangent to the given circle at the point on the circle as shown. Solution. Given, the equation of the circle at the point is as shown. To find the equation of tangent, we need to know the point and the slope of the given circle. The given point is. Now, we need to find the slope of the radius. The general slope equation is as shown. Substituting the center of any circle minus g minus f in this equation, we get. Now, we want to know the center of the given circle. Let's find it first. To find the center of the given circle, just compare the general equation of circle and the equation of given circle. Therefore, we get the value of g and f as shown on the screen. Thus, the center of the circle is. Substituting the given point and the center of the circle in the slope equation, we get. We already know that the normal is perpendicular to the tangent. That is, the tangent is equal to the inverse of reciprocal of the normal. The slope of t is equal to minus of the inverse of the slope r. Therefore, we get slope of the tangent t is. The general equation of point slope form is as shown. Substituting the given point and the slope in the equation, we get. Taking the denominator 4 to the left hand side, we get. Simplifying the equation, we get. Rearranging the equation, we get. This is the required equation of tangent to the given circle at the given point. What is normal to a circle? What is the relation between the normal and tangent to a circle? Tangent is the negative reciprocal of normal. Also, the normal is the negative reciprocal of the tangent, because they are perpendicular to each other. Now, let us derive what is the equation of the normal to a circle. To find the normal to a circle, let us consider the tangent to a circle equation. We already know that the normal is nothing but the negative reciprocal of the tangent. Substitute the relation between the tangent and normal in the equation of tangent, we get as shown on the screen. Separating this equation, we get the required equation of normal to a circle. Note, if the circle is as shown and it has points of parametric coordinates, then the equation of the normal to the circle is as shown. This is called the slope form of the normal to a circle. Let's solve a problem based on normal to a circle. Find the equations of the normal to the circle at the point as shown on the screen. Solution. The equation of the normal is. To find the equation of normal, we need to know the point and the center. The normal at a point is 5, 6. Now, we want to know the center of the given circle. To find the center of the given circle, just compare the general equation of circle and the equation of given circle. Therefore, we get the values of g and f as shown on the screen. Now, we know the center. and the point on the circle which are enough to construct the circle. We are aware that the normal forms at the point 5, 6. Hence, the tangent also forms at the same point 5, 6. Substituting the given point and the center of the circle, we get, simplifying the denominators on both sides, we get, simplifying the terms, we get, cross-multiplying the terms, we get. On further simplification, we get the equation as shown on the screen. This is the required equation of normal to the given circle. Let us summarize what we have learnt. Equation of tangent to a circle at the point P of x1, y1 is x into x1 plus y into y1 plus g of x plus x1 plus f of y plus y1 plus c is equal to 0. Equation of normal to a circle at the point P of x1, y1 is x minus x1 by x1 plus g is equal to y minus y1 by y1 plus f.